guys, so now let's try to do the how IPSec troubleshooting we have to do in your Palo Alto Firewall. What are the things we have to consider, and we will also validate your main mode exchange process one more time by running the debugs basically in your Palo Alto Firewall. Okay, so for that, what I will do, I'll go here and I'll just need to do one small thing. Clear VPN. I कैसे clear VPN IPSec essay. I will clear these essays first. Let me enable the debug. Let me enable the capture here on F0x0 interface. Again, encryption enabled because we have a tunnel monitoring enabled, right? So we have, let me just disable this tunnel monitoring. Otherwise, what will happen, guys? Your tunnel will come automatically on basically. It will try to send the packets again and again. I have disabled this tunnel monitoring because I just want when I will initiate the traffic, that time only I want the tunnel actually to be up. So that's how only we will able to validate the things. Disable this tunnel monitoring. Do the commit. Right now you can see you are able to see the continuous packets. These are the monitored packet basically. Just wait for this to commit, and after it I'll just run the debugs. And also guys, let me just tell you now, if I run this command, so come on, system software status. So guys, in your IPSec VPN, the first daemon of your Palo Alto Firewall who involved is your IKE MGR. The full name is IKE Manager. This is the daemon which involved in your IPSec process, IKE MGR. The log file of this daemon is available inside your mp-log directory. The file name is ikemgr.log. The second daemon who involves in your IPSec is CryptoD for maintaining the cryptographic related logics to create your private key, public key. All this key creation is done by the CryptoD daemon. And this daemon you can able to see here. I'll go on top little bit. This is the daemon CryptoD which is running right now. And after that, the third daemon who involved in your IPSec process is key MGR, key manager, who will basically maintain your crypto keys, these SKIDE, SKIDA, SKIDD. Which daemon will do all type of calculation, right? Who will maintain, who will load these keys, who will do the rekeying? Everything is done by the crypto. Everything is done by the key manager, this daemon, which is also running fine right now. And after that, we have a fourth daemon with the name of tunnel D. This ICMGR, Crypto D, and Key Manager, these daemons is available in your management plane. And Tunnel D is a daemon which runs in your data plane. This is the daemon who will process the traffic which is coming for your VPN related traffic coming through the tunnel, right? This is the daemon tunnel D. Right now, because this is a VM, in virtual machines, we just have a management plane, data plane and a management plane segregation we have just at the software level, right? So that's why we are able to see the log file of this daemon inside MP log directory. Otherwise, in production environment, you will see this daemon log file inside the DP -log. You will see tund.log file. In your hardware boxes, this is the directory DP0, DP1, DP2. You have like that. If you have 3 data planes in high-end boxes like 50 to 100 series boxes. And the fifth daemon which involves in your IPSec related configuration is MP relay. This daemon MP relay. What is the use of this daemon? This daemon will take care your next hop related decision. He needs to send the sorry guys. Like firewall needs to send the traffic through the tunnel interface. What is the next hop? So next hop related logic is maintained by the MP relay. This daemon is also a part of your data plane. This daemon runs in your data plane. So guys, these are the process or these are the daemons inside your PAN-OS who will take care your IPSec related functionality inside the Palo Alto. Okay. Now, the main daemon is your ICMGR who will maintain everything. Your ISAC emp logic, all the packets who will create, how they will send is done by the ICMGR daemon. Now you can see commit is succeeded at both the end. Tunnel is up at both the end. Let me just run this command. Clear VPN ISA gateway. For which gateway I want to clear the session for this gateway. Then clear VPN IPSec SA. For which tunnel? This is the tunnel. I will clear VPN ICASE and clear VPN IPSec SA. Do not run these clear commands blindly in the production environment. If you want to bounce a tunnel, you can just mention the name of that tunnel. Okay. If you will run this command in this way, clear VPN ICASE, it will bounce all your tunnels. Now you can see it is down. Here also it is down. Let me just start the captures again. We will take the Wireshark captures and we will see the other things now. Okay, cool. Go to into the firewall one, run this command debug, IC global and run debug at the dump level, because guys, do not try to run this command in production environment. It is not meant for production until required. Okay. If you want to really do the advanced level troubleshooting, then only try this command. But you have to be pretty sure. Otherwise, your CPU of your firewall gets triggered. Okay. So do not try this command at the dump level. But this is my lab environment, so I can do anything. That's why I'm doing it. I will run the debug into my IPSec process at dump level, at the advanced level, at the highest level. Now I run this command tail follow yes mplog ikmgr.log. I will see the, I want to check the live logs, what's going on there. Go here. After running this command at the dump level, this debugging on this daemon. Now just do one thing. Now just initiate some traffic. From branch of his router. Telnet 10.1.1.100. Test password is Cisco. So versions. Now tunnel is came up, right guys? Control C. Here also Control C. Stop the captures. Now we will go on top. You can see here. From here your main mode is started. Message number 1, 2, 3, 4, 5, 6, 7, 8, 9. And after that all the messages are encapsulated inside the ESP. Right? You can check your message number 1 here. Just check the details of your message number 1. This is the initiator SPI D3 and ending with 92. Go into your firewall 2 on top. Now these are the logs, guys. Now we are going to validate these logs. Okay. Now you can see your phase 1 negotiation is started as an initiator in an initiator mode. Go into your firewall 1 as well and go on the top. From where your phase 1 is started. Just go on top. Okay, cool. So guys, your firewall 2 here started the communication. So you can see phase 1 negotiation started as an initiator. That connection is initiated by 171.7.250. This is the source IP address of your firewall 2. And this is the source port, which is 500. This packet is sending towards 151.7.250. And this is the destination port. Then you can see the cookie value. This is the cookie value. This is your initiator cookie. And the cookie value for responder is 0 right now. And in your Wireshark capture, you can validate. This is the same cookie value, guys. Means what it proves? It proves they will exchange the cookies basically. CI value they will exchange message number 1. This is your message number 1. This is your message number 1, and you can see this cookie D3 and ending with B92. D3 ending with B92. This is the right one. After that, what he has done? He has created some payload. He has created a vendor ID payload, BID. And he has created some other payload as well. And what he has done? He has sent one message of 600 bytes towards your firewall 1. This is the IP of the firewall 1, right? You can see 600 bytes message will be sent over socket number 1024. And if you will go into your Wireshark captures and if you will check the size of your packet, what is the size of your packet is 600 bytes. Means we are looking the correct packet in your Wireshark, right? Now go into your firewall one. Go on top here. You will see a 600 bytes message received means my firewall one here received one packet of 600 bytes from your firewall 2, and this is the information on that packet. So we can able to see all the information of that packet as well, right? This is the information in your packet. Okay, so give me 1 second. Let me put my phone on. Okay, cool. I'm not looking into the chat, guys. Okay, let me just complete this part. Okay, so now 600 byte I have received. This firewall has received. Now what it will do? Now it has just start processing this packet. Phase one state change. Phase one state change means now it's no. We have received the packet. Now I have to start the phase one. New cookie. He has created the new cookie. Cookie is generated that time only. And phase one negotiation is started as a responder. Firewall one is a responder, right? And they are using main mode for that. Initiated assay is this. This is the destination IP. This is the cookie which we have received from the initiator, which is CI. And this is your CR. And this cookie is calculated. How they used to calculate? What are the parameters they are using? They used to do the MD5 hash on source IP, destination IP, random number, time, and date, right? It's a 8 bytes of number. And these are the 8 bytes. And after what he will do now? On this in this packet, now he has started processing this packet, 600 bytes packet. It has seen this packet. There is some security association payload. There is some vendor ID specific payload. Vendor ID RFC is 39774. It supported a NetT. Receive vendor ID payload. DPD is supported. Remote DPD is also supported. Received vendor ID is PAN-OS. Now that's how they get to know what is the other end device. I have mentioned, right? They used to exchange this vendor ID. If you remember here, he will send the vendor ID, and now my firewall one, he received the vendor ID and he just gets to know this is the PAN-OS, a new generation firewall. Remote is PAN-OS now. Selected NetT version is this. NetT is also they are exchanging NetT's payload, and you can see NetT is selected. And after that, what they will now they will start. If you will go into your captures, vendor ID they will get to know, DPD they have validated, NetT also they have validated, right? Supported or not. Now this is your security association payload. These are the security association payload, right? Encryption algorithm and all these details here. Now we have a multiple transform payloads, right? 12 type of phase one policies I have received. You can check. I have received a 12 payload and you can able to see all of them. So it is just making. This is the first one. It is making, right? It is creating all the 12 payloads. And after that, what it will do the comparison. See, proposal number 1, 12 transform sets. Now see, it is checking the details. See, he has started the comparison between the phase 1 policy which we have configured into your firewall 1 device with the received phase 1 policies. Lifetime is matched, encryption type is matched, encryption key is matched, hash type is matched, preset key is matched, Diffie-Hellman group is mismatched. Now it will do the again comparison for the next. It will do the again and for the next, and it will use to do the comparison with all the 12s. And if it will match any, you can go here in the down somewhere. See, now it has matched. Lifetime they will use 8 hours. Encryption they will use AES. Encryption key length they will use 256. Hash type they will use to SHA-256. Preset key they will use as authentication method. And Diffie-Hellman group 14 they will use as a DS group. And this is a accepted proposal. If guys, they will not, if your phase 1 policy will not match on both the devices, what you will get? You will get here, no acceptable proposal found. If you will get, so you are getting this message, an accepted proposal found, because now it has found the accepted proposal. Now it just changed the phase 1 stage from message number 1 to 2. Now what it will do, it again, it had also started created the message number 2 now. And it has created a message number 2 of 140 bytes. See the difference. In message number 1, 600 bytes, and message number 2 is 140 bytes. Why this message is so big? Because here we used to get the entire combination of your phase 1 policies, right? But here it will only be send the accepted one. Now you can see. And it has just sent this message over a socket towards your firewall 2. This is the firewall 2 IP address. Now let's see here if we have received the packet of 144 bytes on your firewall 2. I received a packet of 144 bytes from my firewall 1. This is the IP address of my firewall 1. These are the content of that particular packet. It will start processing this packet. It gets to know vendor ID is PAN-OS. Remote is also PAN-OS. Net is supported or selected. Right? It will also check the send phase 1 policies, right? Because it will just send one. An assertive proposal found. Phase 1 state change. Means now they have just agreed on your phase 1 policies, what encryption method they have to use, what hashing method they have to use, what authentication method they have to use, what is the Diffie-Hellman group they have to use, and what is the lifetime of your phase 1. All these parameters they have negotiated, right? By exchanging message number 1 and 2. And after that, what he has done now, you can see. Diffie-Hellman modulus DH mod P2048. They have changed the phase 1 exchange from 3 to 5 now. And now what they have computed? They have computed DH private key. This is the DH private key, guys. What I have told you. If you remember what they used to create this public key and private key combination. And after that, they will create these values. You can see here. Private key is created. Now with the help of this private key, they have computed the DH public key. Right? This is the DH public key which they have computed. They have created the hashing of this one. This is your, in message number 3, what we have a net D payload, right? Or not? This is the net D payload they are creating. They are doing the hash. They are doing the hash of your peer IP address, right? Source IP and destination IP. Source socket and destination socket hashed. They will add the net D payloads on the packet. They've created one packet of 380 bytes and that packet they have sent. So message number 3 is 380 bytes. You can check here. Now you will see here, we will receive a packet of 380 byte on my firewall 1. This is the information on that particular message. Now if you will go into message number 3 here, this is message number 2, right? You can able to understand this message number 2 content easily. SPI number and all, right? Then here security association payload. You can see here what it is, just having the security association payload. It just have a one payload only, right? It just have a one payload, right? Because it will not send the multiple combinations. Okay, just remember. You can see here. They've agreed on 2800. This is the time. 28800 seconds. AES CBC. Size it to 56 bit. Encryption authentication method is preset key. And SHA-256 as a hashing algorithm. On this only they have agreed, right? Now you can go directly into message number 3. Check the size of your message number 3. 380 byte. This is the correct packet. Go here. Now see the information in your message number 3. What it is having? Initiator cookie and responder cookie. Nothing here, nothing here. It is having the key exchange. What is the key exchange? This is the key starting with CDF. CDF3A. Go here. This is the right correct key. This is the key. This is the value of your X. What is the X value? I have mentioned here 14, but in actual it looks like this. It's look like this. Okay. Apart from this, it will have some nunch value. This is the nunch value. D5E8, D5ED. And this is the net D payload, and this is the net D payload for this is the net D payload for hash of address and port and hash of address and port. Now you can go here. Now this message received by this firewall. Now it will do the processing. So what it will do? It will do the hashing to check the net D payload if there is any net device. Net D is verified. They are using the hashing algorithm 256 for creating this net D payload and net not detected. If there is any net device, they will able to detect with this particular payload, right? Now phase 1 state has been changed 3 to 5. Now let's see. He has also created this public key and private key combination. This is the public key. And after he needs to generate this Y value, because Y we have to send this 8 value. He has generated this one. This value he will send is starting from 095. If you go into the next message, which is this one, starting from 09583A. This is the correct value. And they are exchanging this value, this key, even though we can able to get it from the firewall as well, right? He is creating the net D payload and he will send one message of 380 bytes will be sent over towards the other end. Now other end will receive this message of 380 byte He received the message. This is the message content. Now what, he will do the net verification, everything. Now what, they will compute the DS shared secret, this key. They will calculate, and here also he will calculate the DS shared secret, this key. What is this value? I'm talking about this DH key. DS shared secret, which is 9 here and 9 here as well. And you can check this value is similar in both the devices. This is the computed DH key starting with F1C9 ending with 19A3. F1C9 ending with 19A3. So they have calculated the correct key or not? Means they have calculated the correct key, guys, right? SKID. This is your DH key now. Now, if you have this DH key, they know the preset key. This is the preset key in your encoded format. They know the nunch value, nunch1 and nunch2, NI and NR, and what they will calculate. Now they will run the HMAC using the SHA-256 algorithm, and they will compute the SKIDD, this one. SKIDD, HMAC or preset key, and they will use NI and NR as a value. And they have created this SKID. This is the SKID value. And you can see this device will also do the same calculation. They know the preset key, they know the nunch value, NI and NR value of each other, and they have created this key. This key is similar, starting from A0FE ending with 20B0. A0FE ending with 20V0, same key. Now what? They will create a derivative key. They will create a SKIDA, then they will create a SKIDE. And you can see all looks similar. E ending with 2B, you can see here as well. SKIDD, SKIDA, and E, and all are similar. See, D to B. Means they are doing the same calculation, guys. Now, once they do the calculation, now what? They will create a final encryption key. This is the final encryption key. This key now they are going to use to encrypt your message number 5, 6, 7, 8, and 9. And you can see this final encryption key here as well. 84054 ending with D2B, ending with day2B, and starting with 4054. If this is the right key, which means we can able to decrypt these message number 5, 6. This message, right? See, they are encrypted right now. Right? If this is the correct key, means we can able to decrypt these messages, right? Or not, guys? 5, 6, 7, 8, 9. We can able to decrypt these 5 messages. Right now encrypted. Now let's try to do the decryption of them. Protocol preference, or do one thing, how we can decrypt. You can go into the edit, preference, protocol, select here ISACM, I version 1. Now do one thing. What you, for that you need an initiator cookie, and you need a final encryption key. So just copy this key, go here and add this key. And you need an initiator cookie. So initiator cookie, how you will do that? You have to go to on the top. Sorry about that, guys. And this is your initiator cookie. Copy this, go here and paste. Okay. Okay. Now this is your message number 5. Now encrypted content is visible. We can able to see this content, which means we are using the correct key, guys. Now in message number 5, what I have told, they will exchange they used to exchange this IDI payload, identity payload, and identity payload. What they've generally sent, he will send his IP address. This is the IP address as an identity payload. This is my IP address, and they will send the hash I. This is your hash I. IDI and hash I. These are the values. Other end also do the same thing. If you will go into the next message, you have the identity payload from the responder, and it has have the hash I value, right? These two values. IDI and hash I, IDR and hash R. How they will use to calculate these values? What are the content is available there? So give me 1 second. Let me go here. These are the value he will use to create this hash I and hash R values. Okay. And these are the values. Now we have decrypted these messages or not with that key. Now you can just move further. Page 2 is succeeded, but I want to look for page 1. Still, so I'll go on top. Final encryption key is created, right? Now what they will do? Using the ID type IP address, they are just creating the hash I value, and they have created one message like this. Computed the hash and other things. And they've sent the next message of 92 bytes. Just see the message number 5 bytes. It is 92, or how it is. It's a 92 bytes, which means it's a correct message. Now this 92 bytes is received by this device. You can see it has received the 92 bytes message. Now you can see what it will do. Now it will try to process this message. It will validate the identity here. Whatever identity payload he will send, he will validate that payload here. Because this peer identity we have configured, right? They will use IP address as a identity payload. Now what? He has started processing these 92 bytes. Because these bytes are encrypted, so he needs to do the decryption. He has decrypted the payload. After the decryption, it will start checking the things. Has received, this is the hash value which we have received. Hashed with this, hashed computed, hash for preset key is validated. Means this is how they will do the validation, guys. Peer IDs is validated using ID type, IP address, generate the hash R. Now they are generating the hash R values. And after generating all these values, hash R value and IDR value, and what it will do, it will send the 92 bytes towards the other end. And you will see here it will receive the 92 bytes. It has received. Come on. Just go on top little bit, guys. Mhm. 92 byte received from my firewall 1. This is the IP to the firewall 1. It will do the validation now, and you will see it has decrypted because it has received the message number 5, message number 6 in an encrypted form. It decrypted, right? And after the decryption, what it will do, you can see here one succeed message, succeeded, right? He is able to succeeded, he is able to successfully decrypt the message, and the received has is will do the validation, and that's how they will validate the pre-shared key. They have not shared this pre-shared key. Whatever keys they have created, they have utilized them. They have used this pre-shared key in creating these keys, and these whatever keys they have created as KID, E and A, they are using for encryption and hashing purpose, right? If other end able to decrypt the data properly, which means they are communicating with the right person. They will validate the peer identity, and that's how your phase 1 is completed. Now you can see phase 1 negotiation is succeeded. This is the initiator cookie and responder cookie. This is the lifetime, and after that your phase 2 will start in quick mode. So guys, this is how your see phase 1 negotiation is succeeded. Now your phase 2 will start. Now you will see here phase 2 negotiation is started in quick mode. Now in phase 2, what happens in quick mode message number 1? You will see nonce value again. You will see the proposal. These are your phase 2 policies. You will see the transform set, tunnel mode or transport mode. You will see the X. Again, they will exchange this X value. But this is a newly created X value. So I can just put here X dash. And you will see some proxy IDs. If you are using, if you configure the VPN with ASA. Then why this is also, you can go with NI dash and NR dash, because these are the new values they are going to exchange. If we have enabled the PFS, that time only you will see this NI value and X value, because now they again they will again initiate the phase 1 and phase 2 calculation, because we have enabled the perfect forward secrecy. If PFS is disabled, that time X dash and Y dash not exchange. If PFS is enabled, that time X and Y, X dash and Y dash are exchanged. Also, they will use SKIDD for creating the new session keys. They will create 3 keys, which are SKIDD, SKIDA, and SKIDAE again, guys. That's how your message number 2 exchange is completed. Now you can see phase 2 started. They needs to do the encryption of your phase 2, right? They will send, what is the DEFI element group we are using for PFS? Your DH key is computed, means your X dash is computed again. Compute the DH public key, means this is your X dash. IDCR, right? They have created the nonce value, and they will send all this information. You can see one packet of 412 bytes it sends towards the other end. Now what other end, you will see it has received the 412 bytes, and it will now do the processing. Now he has just started the phase 2. Decrypted the payload, because you know they will receive the encrypted payload. They will check everything, they will validate everything, right? He will see in some proposals, and it will match your phase 2 policies as well. See, it has just started the matching. And you will see there is a one match found. There is a one match is found. Peer single bundle, right? You can see all the details they generally use to match, and everything they used to do here.
Now he will also create one more packet again, right? Will compute the DH public key and all, and he will forward the message, right? Compute the DH secret, right? And again they will do the creation of these key mat compute keys. These are the new keys, right? And after that, once they will succeed, they will create this as the service parameter index number. And if you will see here, this is the key they have created for hashing purpose, auth key. And this is the key which they will have created just for the encryption purpose. At the end, they used to create these particular session keys. Here also you can able to see the same thing. Go at the last. This is the key for authentication, and this is the key, auth key. This is your encryption key, in key and auth key. These are the two final keys. And once your phase 2 exchange is completed, all the packet they will come in a ESP. And in ESP, everything is encrypted. You cannot able to see anything. But till here, message number 7, you can check what are the information is available in message number 7. Initiator cookie, responder cookie, version details, check the flag details, encrypted data. In encrypted data, you can see the hash data. This is the hashed. Basically, they will validate just for the integrity purpose. And after that, you can see what they are using, IPSec ESP, right? This is the lifetime in seconds. This is the lifetime in second, which is 1 hour. Encapsulation mode, I'm using tunnel mode. Authentication algorithm, I'm using SHA-256. DEFI element group is 2. Everything you will see here. All the combination of your phase 1 policies. Sorry, phase 2 policies. And you will see some proxy ID, which is 00 right now. By default, it will send all zeros. This is the next message. You can validate the things. This is the key exchange data. This is the nonce data. It has everything. This is the final message. And after that, everything is encrypted. Now, because you know this packet is also encrypted. Now let's try to decrypt them so we can able to see everything. Edit, preference, protocol, ESP, edit. Now here we have to define the details. Add IPv4. What is the source? Source IP address is 171.7.250. Destination IP address is 151.7.250. Again 151.7.250 because there is a bidirectional traffic, right? And 171.7.250. Let me just make some space here. Okay, now we have to define the SPI number. So you can go into any firewall. Let me just get that details from my firewall 2. In firewall 2, if you will see, this is the security association database. If source is this and destination is this, then the SPI number is this. Copy this SPI number, go here and put this value.
If source is this, destination is this, then what is the SPI number? Source is this, destination is this, then SPI number is this. Just copy this SPI number. SPI number is service parameter index here. Now, what is the encryption algorithm they have negotiated? They are using AES 256 bit. So just type here AES CBC. Now here also AES CBC. Now encryption key. What is the in key from this source to this source? This is the encryption key. This, copy this key till here. Go here. Just put this key. You have to add 0x and you have to copy whatever you have copied. What is the authentication key? This is the authentication key. Go here. 0x. And what is the authentication algorithm? It is SHA-256. What is that details? SHA-256, right? So look for here SHA-256. HMAC SHA-256 96. Just select this one. Okay. Now select the same here as well. Now we have to look for the encapsulation key in key from this one basically. So this is the in key here. Starting from here till here. 0x, Control V. And the hashing auth key is this. Copy this value. Go here. 0x, Control V. Click on OK. Click on OK. If you are lucky, then your packet is not. I'm not able to decrypt them. Why? So there is some problem, not an issue. I'll go here. SPI number is 0x95E4. For this, we just have this AES CBC. Only we have this format for CBC. Okay. Go down. It's done now, right? Because we have selected the wrong hashing algorithm. Hashing algorithm I have corrected, and now you can see I can able to decrypt them, right? What I've initiated the telnet packets. I can able to see all the telnet packet, guys. So now you can see here I have decrypted the ESP packets as well with the help of Wireshark, and I have just get all the keys from my Palo Alto Firewall. So guys, if somebody asks you to check the end-to-end process of your IPSec VPN and Palo Alto Firewall, what's going on, if there is any issue with the logic, if your daemons is not working properly, right? Where you will, this is the way. This is the way to basically do the troubleshooting of your IPSec VPN related. It's easy only, but if you will apply this thing in your lab, that time only you can able to do that. Otherwise, it's very complex. So this is it, guys, in your IPSec VPN, and this is all about your IPSec VPN, which I want to discuss. And if you want a, I do have one more course on IPSec VPN guys on our portal. If you want to see all the all the use case of this IPSec VPN, I'll highly recommend you can opt for that particular course as well, where you will see all most of the use cases of your IPSec VPN related config. Okay. And if you have this much knowledge of your IPSec VPN, that is more than enough to crack any interview and to do the troubleshooting in your Palo Alto firewall. Thank you very much.